Good afternoon and good morning, and welcome back to this short webinar. Today we are, thanks to be hosting by ConocoPhillips and Total Energies. So this is two companies want to expand your LNG portfolio, and today we are discussing the new type of LNG production and perspective in circular economy. We are starting to define for people what we can say about the type of LNG. LNG is the type of gas compression and liquefaction that can be produced in various ways. So we have the principal 5 topics of that discussed today: the type of LNG, the major project of these two companies are involved and will be invest, the economic analysis of LNG built up and production, how ConocoPhillips invests in environmental prevention and compensation measurements, and so the new technologies of compression and storage for LNG. We are starting to a brief summary of resume of what we intend to do with LNG. The primary methods to LNG production, we have 2 different types today. We can extract gas. It's the conventional and upstream and midstream from conventional fossil fuel LNG production. We process the fossil and natural gas, after in the midstream we have the liquefaction process, the pretreatment, the acid gas removal dehydration, the fractionation, that is the key processing for the separation of conventional gas into GPL, methane, bioethanol, like this. After we have the cryogenetic and cooling liquefaction, so the cryogenetic and heat exchange and compressor, and we have the LNG system to ship. So generally we have to ship this compression gas through the boat, specialized boat that store this gas and make this. So we have also a new type, in this case also in Italy, for example in Emilia-Romagna region, that we experimented this new type of LNG production just about 10 years ago. The bio-LNG production processed for non-fuel biogas, but from organic waste, landfill gas, food waste, agricultural residual of animals discharged like this. We have the biomethane upgrading and liquefaction, the anaerobic digestion, and we have also the upgrading removal CO2. We have the separation. We have like a fermentator in this, and you can separate the CO2 from the gas. After we have a small scale cryogenic liquefaction and the biomethane storage. That is another way to separate the CO2 to the methane. We have the biomethane storage, and after we can use them for local economy, for local production, or can be distributed to the network, to the common network. We have the comparative table of summary advantages of 2 types of principal energy. The conventional energy, it's clear to product that have a high quantity of emission of CO2. So the resource type is clear that is fossil. The feedstock flexibility, we have clearly a big availability of this kind of resource with gas field, and is easy to shape with both like this. So the LNG is another way to bring and to follow out the net zero parameters of the next 10 years. The resource type is essentially renewable. and that will be increase in the circular economy. So the feedstock feasibility is local waste. This is a brief summary of the two-type production of LNG that today is possible. It's clear that we can, in the next slides, we are considering what kind of moleculars can be a part of LNG project, because there is not only methane can be engineering to energy transportation. So there are also like other moleculars. There are the primary energy carriers that the goal of liquefaction process to concentrate to the methane, while separating either components for sale are separated the same products like ethane, that is another gas, much more important, often left in the LNG mix in small amounts to increase the energy of density. We have also the propane and the butane. Now, as the LPG, the liquefaction petroleum gas, there is the second component, that is the EV component of the LNG. So is the EV component is the LPG, that is a group of EV gas, and LPG means liquefied petroleum gas, while LNG means liquefied gas, normal. So they are usually stripped and out because they have a higher freezing point and have more valuable salt separate. After we have the Pentans Plus, there is a so-called natural gasoline or condensate gasoline. That is much more removable to present from the timing into wax solids and cryogenic section. So this is a summary of all types of moleculars that can be make under LNG compression and liquefaction. We have the methane. This is the principal product that we use in LNG products, but is the only. Is keep to liquefy. We have also sometimes we have also some part of water that is considered like an impurity and is removed. Also the CO2, the mercury, the trace metal, and the siloxane be impurity. So the first question is, what kind of molecules can be a part to LNG project? Is like this, we have just have the first answer, but the second answer, for example, for the bioLNG, specified molecules like a bioenergy project using anaerobic digestion was encoded molecules that not are typical found in the fossil fuel for the reservoir. These molecules are so different from fossil fuel, and is called the siloxanes. This is a silicon-based organic compound found in landfill gas from soap and detergents. It is not removed, too simple to be removed. They turn into silox dioxide, essentially glass, inside the engineers or compressor in oxygen gas form. Must be strictly monitored, because in this process, when you have the bioenergy compound, you can have this the probable formation of the siloxanes, and must be strictly monitored. Oxygen in presence of methane creates an explosive atmosphere, so the bioenergy plants must be strictly controlled, and is a sign of a leak in the digester. Also, the frequent presence of ammonia, common in biogas from animal manure. It is like corrosive to copper-based, allowing the cooling system. So it depends which is the best found to generate the bioLNG. And if you have, for example, a high concentration of animal manure, you need much more attention to corrosive phenomena. which are the molecules that enemies of LNG plants. There are also two types of molecules. Molecules that you need to think that a gas reservoir, a standard gas field reservoir, is not composed but only methane like this, but we have a mix of gas. Starting from the simple case or real case to the extraction of gas from gas field reservoir, you can make attention to separate some molecules to the mixing molecules that you have in gas reservoir. So there is some molecules that are enemies of LNG plant. Because why are enemies? Because if they are not removing during the pretreatment phase, they will turn into solid days or in snow inside the cryogenic heat exchange. So they are very dangerous and perilous for the security of the system, plugging the system and causing a shutdown. For example, if we have a content of water measured than 0.1 part per million, you can have this kind of phenomenon that turn into ice or snow into cryogenic heat exchanger. Having a thin amount of moisture will create ice block at cryogenic temperature. So the carbon dioxide usually to be limited to 50 parts per million at the temperature at minus 162 Celsius degree. At this critical temperature, CO2 turn into dry ice, which can be erode or block the narrow channel of plate finite. So this is the brief, the turnaround consideration that these two companies, in particular ConocoPhillips, are working with us for develop new kind of technologies and affects the inert gases. And so we have also the presence, sometimes we have a great presence of hydrogen sulfonide, a toxic fuel gas that is highly corrosive to piping and must be removed for safety and environmental revision and environmental reason. So the effect can be clear. These molecules don't burn and don't be freeze easily, so they take up valuable space in a single tank of 200 liters of LNG ship. So we have sometimes also the presence of gas nitrogen, often found in natural gas, because its boil point, they can be altered, the boil point, if even lower than methane, and usually flashed off at the end of process. So if there is too much nitrogen and the LNG won't stay, could say, effectively. So the helium occasionally can be found in gas fields. Sometimes in the energy platform have a side unit to capture helium because it is extremely rare and valuable. So it's clear that sometimes the presence of this can be detected previously and separate for commercial use. But there are some enemies molecules that are water, carbon dioxide, and hydrogen fluid that can be excluded to the final liquefaction process. So we are working to strengthen partnership to the company to try to new solution to solve these problems. The following table provides a normalized, levelized cost of production is referred to the last period, and average cost to build and operate it and plan over its lifetime, expressed in USD million dollar. The metric is related to the cost of getting the gas out the ground and producing fuel rather than final spot marketplace. It's clear that we are talking about a very big project, so the typical cost of production, we have the three best categories at this moment that are available. So the conventional gas drilled, and so the typical cost of production is between 1.50 to $5. And so we have the comparison also for unconventional gas, the shale and the tight gas. That is, the price is really similar because we are generally starting for a major cost, for a highest cost in starting production, but is not so different because we start for 2.5 to 7. And we generally apply frac technologies, cost well density, depletion rates, labor, drilling service. To the last technologies, that is the renewable technologies, will be the bio-LNG. It's clear the bio-LNG actually have a typical cost of production that is around from 2 or 3 for the standard cost production of gas. The feedstock type, which is the trouble, for example, this is the feedstock type to create a typical plant scale, the liquefaction efficiency, and also the logistics. We can have some note that, for example, for bioenergy, the high current cost due to its emphasis on small-scale operation, because generally a BLNG plant is really small. We can produce around 2,000 to 200 feet meter cubes per year, so it's really small plant, and it often requires significant policy incentive for a carbon certificate to be competitive. So about the unconventional gas, conventional natural gas, we are talking about in one of next webinar. So we are starting to work with ConocoPhillips to develop these kinds of projects. Cost has dropped significantly in last 15 years due to hydraulic fracturing and horizontal drilling advantages, and particularly in North America. But also this, we have some innovation for this company. Currently, the lowest cost fossil fuel to produce associated gas by production of oil drilling can be the lowest and at this range. So in summary, we can underline that the bioenergy remains significantly more expensive to produce than its fossil fuel counterparts due to small economies, but we have the advantages for the environment and like this. And the scale of agricultural waste management required to produce the feedstocks. We can make also a comparison between conventional and unconventional gas. While conventional gas is often cheaper when reserves are abundant, a conventional gas can match or beat conventional costs in a specific profile region, like USA, Permian Basin, or other region, due to optimized technologies and massive scale. It's clear that today we are much talking about the unconventional gas because some states or some nations want to develop is independent, and so some small basin is based have a reserve on unconventional gas. Summary difference: the impact of carbon price is clear. The price gap between the bioenergy and natural gas is filling between the impact on the West and significantly when well due to wake emission accounting is applied. Under trading system, the regulation of UE and ETS fossil fuel carrying emission penalties, whereas bioenergy, especially when made from menu, can receive negative emission credits, so reducing its actual market cost to end user in those specific markets. In this slide, we are make a cost comparison, cost structure overview for LNG production analysis. We have it's clear different different ways of cost analysis for create an LNG plant. For the first is the natural gas purchase or gathering. Generally, we need to pipeline, transportation, commodity price. So, but if you make an LNG, this we cancel the structure of transportation. The impact in total cost is minimum. Recent innovation, advanced asset optimization. The upstream and midstream, so exploration, production, drilling cost, field life, complexity. We have a high capex. Generally, for this kind of project, we have the high capex. So, generally, the company invest in this project because are sure that we have a return. And the plan OPEX for plant operation and maintenance, power consumption, we have a much more part that is dedicated to engineering for the compressor laboratories and like this. We have the plant CAPEX, the liquefaction plant, and the cryogenic system. Technology's choice is much more important to efficiency and the duration of plant that can be generally with this kind of plant can be have a life cycle around 20 or 13 years. Okay, we have some innovation that we will show you in the last part of the webinar, like the new type of boil with 9% on nickel steel reduction, the modular cryogenic units, and high efficiency X-proof motors. The logistics and shipping, storage and marine transport, the LNG carry sites, voyage distance, fuel cost, and boiling off. So we have the different color to underline the impact cost on this kind of projects that we are generally medium to high. Which is the situation for the company ConocoPhillips in this moment. We are involved in totally 5 projects. We have 2 projects in Australia, in IPEX Australia and QLNG Australia. We are involved in Atlantic LNG, Equatorial LNG is the major projects of company. And so in this project we are testing the new technology to refine and to separate molecules, make correct analysis of gas and geochemistry. About the other partners like Total, we have a big project in Mozambique that is called Mozambique LNG. So it's based on northeast part. So we have a map that show you the localization. This is a complex project will be provided also the construction of pipeline for internal and domestic user. And about the geological framework of this area, this is a complex geological framework because we are working in a sediment passing along the Mozambique margin formed during the extension and breakout of Eastern Gondwana. And the late Carboniferous Triassic age rocks that is called the Coro Formation and the early mid-Jurassic margin rift system guides the formation of gas during the separation of Mozambique from the eastern Antarctic and Madagascar from the mid-Jurassic. The three main events create the transfer zone to separate the margin to the basin system. We have also some image of the structure of the subsea structure, regional geology, and underline a compressive structure faulted in ocean reef, where incident subduction margin underline in the seismic section with the principal 1 of 2 points oil spill. We have also the the ancient platform, cratonic platform, that will be faulted and after was remarked by the Davis subduction zone. The source rock in the system was found in the Cretaceous rock and the reservoir in Paleocene and Eocene sediment, while the silt trap was made by the recent sediment of the mid-Oligocene structure. We are estimated the reserve around 30 billion barrels, and we are recoverable this value at this moment. So about the company ConocoPhillips that we have in partnership, the strategy for this year is to use its stabilizing and international assets, in particular in Australia and Africa, to offset the potential margin compression caused by the global supply for LNG. In Equatorial Guinea, we have an hub expansion that is proposed to be started to the construction by the end of the year. Following the financial department investment, the ASEC gas project is now moving into rapid development. This will provide a lifeline and new gas volume for the Punta Europa complex. So the ConocoPhillips is expected to see new production sharing contracts in this block at the half of this year or at the end of this year. We have also the project that I show you in the project in Australia. Australia PGN, that production stability ConocoPhillips is prioritizing operational depth over volume growth here. Expected steady state production at Curtis Island. Atlantic LNG Trinidad and Tobago status. We have this project is just is an old project, but we are revitalized and resource constate. So this is a regime of project in which ConocoPhillips are involved. They are principal Australia, Equatorial Guinea, that is a regional hub creation with the technical maintenance big log. In Australia, we have established a high cash flow, is a good situation for company. We have some economic analysis of project that the investment and the total capacity and how we expect it to produce in the next 10 years. So the Australia PGN expansion, the high investment range of 20C reflects the new approved expansion in the Surat and Bowen Basin, that are the most two important basins for unconventional gas and LNG production. The construction of near this new well gas and the pipelines will begin at in next 2 months probably. The Equatorial Guinean is a complex project that is just starting, stopping, and now we are starting for the blocks before and AG 24, which will unlock a total $9 billion in long-term capital to process gas from countries. We have also the Trinidad, that is the Atlantic LNG hub. In this, we are developing a new technology that is called the bottle-knocking, and we will show you what we are talking about. What about the bottle-knocking technologies? These technologies is developed by ConocoPhillips, use technologies and two engineering projects designed to increase the production capacity of existing facilities by identifying and removing specific physical or process constraints. These projects are often more cost-effective than building new production trains from scratch. The bottleneck of existing plant can be added an average of 5 capacity increase of production. So we have the standard plant and the bottle knocking permitted an high level of compression. So the bottle knocking is the first step is the identification and simulation of the high data-driven diagnostic of molecules that are presenting and which will be separated and after which will be stocked in shipping. The component upgrades and like this. We have also the optimized cascade process used by ConocoPhillips and technologies that allow to separate, for example, the propane, the ethane, and the methane, and you have the different separation of these three type important gas and also storage in part like this, and we have also the recovery of nitrogen and other important gas. The simplified plan is the typical propane condensate system that allows ConocoPhillips to produce this gas for internal and domestic user. The function of ConocoPhillips optimized cascade process and LNG liquefaction. So this is the typical cycle of production used by ConocoPhillips optimized cascades. From the propane cycle, when we are separated, you have, for example, propane. You have propane. You don't spread propane in waste ambient, but we can a propane compressor, propane condensator, main propane killer, and the ethylene cycle. We can use this process also for ethylene cycle. And we have a narrow passenger for multiple stream flow that is allowed to have the pre-cooled gas, the subcooled gas, and we are in the same tank the different separated gas by density. And it's too easy to make transportation. So, ConocoPhillips are not only involved in gas exploration, but for all of this project, we have a politically and policy that allow investment in environmental prevention and compensating measurements. The near shore, for example, we have the project to replant mangrove for protection and replant, create safe corridors for fishermen. This is an investment environment prevention like this. For offshore in Australia, for example, when we have the two major sites, we are protecting corals reef in Australia with ultraflight carbon fiber sheet and Posidonia ramplant. This is the policy of the company. Invest in environmental prevention and also in South Africa we have a restoration built up geothermal greenhouse. This is another project of compensation. Finally, we present the new technologies that we are developing for ConocoPhillips. This is a composite technologies for storage the LNG after the liquefaction is the optimized 200 cylindrical LNG vessel. The particular is also that is combined with the optimized rotative motor and centrifugal compressor. Why we choose these sites? Because the 200 liter cylindrical is optimal for this dimension, for much more vessel. So we have a ellipsoidal head, inner tanker, and insulation with multi layers and vacuum. We have sear glass and sear brackets, and we have also the water inject and the security. The safety system, system safety law was showing low in flow diagram, because when we are loaded the LNG, we have a system of valve, electric valve that will be controlled from the vessel, and pressure relief valve to set to this value. The very innovative is the motor, the rotative motor at 2 cylindrical with this sources power with high efficient that allow to compression and make the load of energy in a reduction time. The new compression technology uses rotative motor to storage and create electricity for local process. This is a resume of these new type motors used for compression, and the thermodynamic performance that show you that because the gas heats rapidly when compressed is rotative, the cascade cooling logic is vital. The heat management integrate intercoolers and aftercoolers to remove the heat of compression before the gas enter the 200 liters vessel. The turnaround ratio approximately between, we have a great turnaround because we have a percentage between the 18 to 10%. Rotative units are less flexible than pistons vary. And features, so target features that can be used for, it's clear, can be used for methane, for propane, for biomethane. The maximum pressure is up to 250 bars, depending on stage. The RPM range is around this. We have also the lubrication of oil-free magnetic, and the noise level is very low. Is a brief of some technology that we are developing for the company, and so thanks for attention.